Okay, let's continue to review something. This result is known as uh, Pythagorean theorem. Pythagorean theorem says that for any given right triangle, the square of the hypotenuse equals the sum of squares of two legs or other sides. So how to do this? Let's consider big square. The big square is constructed by okay, so this is A and this is B, C, B, C, B, C, B and C. Because the sum of these two angles are half pi, and this is pi, so this is a right angle. Inside is also square. Okay. Now, the area of the big square is B plus C squared. And this big square is divided into 1, 2, 3, 4 right triangles. The area of the triangles is half times BC. Also, this is a square whose area is A squared. Then we obtain B squared plus 2BC plus C squared equals 2BC plus A squared. So finally we obtain A squared equals B squared plus C squared. This is a very important identity. Yes, I think all of you have learned this before. So use this theorem, we obtain this relation. This relation is called Pythagorean identity. Pythagorean identity. Okay, for sine and cosine. Next, there are many relations between 6 ratios, 6 trigonometric functions. All of them can be used. I don't know how to say this. This is not pentagon, huh? Okay, by definition, if we have a theta here, then sine theta is y over r. Okay, when the theta is given, maybe more than 2 pi, theta is given, is a real number, we can choose a point x, y, and compute the length r here, where r equals square root of x squared plus y squared. And sine theta is exactly the ratio of y to r. Cosine is the ratio of x to r. Tangent, y to x. And the reciprocal of tangent, secant is reciprocal cosine, and the cosecant is the reciprocal of sine. Okay. By this definition, there are some algebraic identities. For example, the reciprocal property, two antipodal points whose product is 1， 就是两个对角线顶点的乘积是1嘛。The product of these two functions, these two functions is 1. Okay, the product of these two positions, they are the endpoints of the diameter is 1. Because by definition, these two functions are reciprocal to each other. So the product of these two functions or these two ratios is 1. 1. Sometimes we call this is a reciprocal relation because this one's equivalent to cosecant theta equals the reciprocal of sine theta. And this equation is equivalent to secant theta equals 1 over cosine theta. And this one is equivalent to cotangent theta equals 1 over tangent theta. Okay? This is the rule 1, called the product rule or reciprocal rule. Next, each position, each vertex is the product of the adjacent two functions and two ratios. So we have a sine theta is the product of tangent and cosine. Also, cosine is the product of sine and cotangent. Cotangent is the product of cosine and cosecant. Okay, let's check these three identities. Sine here. Tangent and cosine, tangent here, cosine here. Oh, if we multiply these two numbers, two ratios, then x and x are cancelled. We obtain the y over r, right? Because sine. So this one is obtained. Next, cosine, sine and cotangent. Cosine, sine and the cotangent here. Okay, the product of sine and the cotangent of y, this time y and y are cancelled. The product is x over r, exactly, cosine. And the cotangent, cosine and cosecant. Cotangent here. Cosine the cotangent. Where's cotangent? No. Cosecant. Cosecant is here. Okay. Cosine times cosecant. Oh, this time r and r are cancelled. The result is x over y. X over y. Connect the thing. So, the product of any vertex is the product of its adjacent two functions. Okay, any function is the product of its adjacent two functions. Now we already checked sine, cosine, and the cotangent. If we consider reciprocal, we obtain cosecant by this rule. And reciprocal is cotangent. Reciprocal of cosine is secant. So this is cosecant equals cotangent times cosecant. So this one is also, for this vertex, this identity is also true. Then the reciprocal one, reciprocal, we have secant theta equals cosecant theta times tangent theta. This one is the product of cosecant and tangent. Oh, yes. So this one is also obtained. Finally, the reciprocal of cotangent is tangent. The reciprocal of this one is secant sine. Tangent here, secant sine. Okay. So quotient rule, product rule. Okay. This rule also can be read in this way, because the central one is the product of its adjacent. So this one is the quotient of this and this. I mean, a tangent equals sine over cosine. Sine equals cosine over cotangent. Because the middle part is the product of the adjacent two. So tangent equals the middle one divided by the other adjacent one. This one equals this over this. And this one equals this over this. In other words, you can start from any point. 1 equals 2 over 3. 1 equals 2 over 3 in both directions. Okay? So there are many algebraic identities can be read from this diagram. Okay, so this is the reciprocal 导数关系. This is tangent equals sine over cosine, and the cotangent equals cosine over sine. This is called quotient rule, 商数关系, quotient relation. Okay, finally we have how to say this? Oh. Pythagorean identities. Pythagorean identities. 这是平方关系或叫递数关系。For this three upside down triangles, this one, and then this one. Upside down triangles. We have the square of this, the top two points equals the bottom square of the bottom one. So cosine squared plus sine squared equals 1 squared. This is exactly what we just reviewed on. Now, we divide this by what? By cosine. And cosine divided by cosine is 1. Sine divided by cosine is tangent. Because tangent equals this one over this one. So sine